Okay, good morning class. So today we're looking at the exercise congruency and similarity of triangles. This is, let's copy this. This chapter is chapter 14. We just give a proper similarity. Similarity exercise 1. This one page. And 146. Okay. Okay, so let's look at similarity. Here we are told that prove that triangle ABC, ACE is similar to triangle DCB. Those two triangles. So where do we start? I start by saying in triangle. I name it as they gave it, BCD, and triangle AC. Okay. So BCD, which is this triangle here, and the other triangle being ACE. How do we prove similarity? I told you yesterday, how do you prove similarity? You prove that, two angles are the same. Automatically the third one will be the same. Not so. So which two triangles are the same here? Which two angles in the triangles are the same? Angle ES is equal to BDC. Why? Why are they equal? Both are 90 degrees. Not so. Why? What's the reason? So we're saying firstly is that angle E is equal to BDC is equal to 90 degrees. Why? Why is this 90? It's on the diagram. Let's give it. We need to prove another angle of that two triangles are the same. Which angles are the same? Remember, this is triangle AED, and this was triangle BDC. Which other angle is the same? Angle C. Angle C is actually the same in both triangles. Can you see that? The side, you see that's this angle here, DCB. That angle is the same as angle ECA or ACE. It's exactly the same size. Can you all see that? So we can then say that angle C is in both triangles. So angle C is a common angle. So since that angle C is in both triangles, angle C is a common angle. Later on when we speak about congruency and we have a side that is in both triangles, no? Then you will say common side. You guys understand? Because this angle is in both. It's a common angle. Okay. Then thirdly, what's the last angle we have to give a reference for? Angle A has to be equal to angle DBC. Why? Why is this angle now equal to that angle? Can I say corresponding? No, why not? They're not parallel. Okay? But what did we say yesterday? We said that if two angles are equal, automatically the third one will be equal. Yes?
So can you say it's exterior of the
Exterior angle of a triangle? No. Because if you look at this triangle, there is an exterior angle. So that is equal to that plus that. Or we say this length is extended, so that angle is equal to that plus that. That is exterior angles. Okay. So why is angle A equal to angle DBC? Because it's the third angle of triangle. Remember we said yesterday, if two angles are the same in two different triangles, the third angle will have to be the same. Why? Because angles in a triangle adds up to 180. Okay. People, 3 points is enough to conclude similarity. So what do I say? Therefore, triangle BCD is similar to triangle. So we go B. B was the same as angle A. Can you see that? B was the same as A. C of this triangle is the same as C of that triangle. So it's C. And then D is the same as E of the B triangle. And you'll notice that it is the same as given to us. As I said yesterday as well, that will always be in the correct order. Okay. And what's the reason here? Angle, angle. Okay, we proved that the three angles are equal. That is why they are similar. Okay. Let's carry on. Am I moving too fast? Yeah, move a bit faster. Okay. So now in the next question, we are told, turn this down a bit. In the next question we are told, you'll see from a similarity question, you'll always get a distance question or a length question. Okay. Looking at B, B says calculate the length of A, B, and C. There's lowercase a, b, and c refers to lengths. Capitals refers to the vertices. Okay, you guys understand? So that point there is B, that point there where the lines meet is A, and so on. You guys understand? You got at the back? Are you okay? You're not even looking yet? Alright. So what do we say? We'll start off by saying BC over what? ACS is equal to CD over CE equal BD over AE. Why? Because triangle BCD is similar to triangle AC. Okay. So what is the length of BC? 20. What is the length of AC? 30. Can you see at 20 plus 10? It's 30. And this is my known ratio now, okay? CD, the length of CD, 16. Over the length of CE, 16 plus B, or B plus 16. So you all agree that in this case already I can calculate. What can I calculate here? B, by cross multiply. Okay, let's just first conclude. BD, the length of BD, it's A over the length of AE, which is C. So I can't calculate A or B using this here. Why? Because I need to at least have one of the two. I need to set up an equation with one unknown, not two unknowns. Alright, so what can be calculated here? As we said, B can be calculated. Not so. So I also said that when we're going to do equations, we're going to speak extensively about this. That x over y is equal to a over b. Then you can conclude that bx is equal to ay. You can cross multiply. If you didn't know that, make a note. You have a fraction on either side of an equal sign. One fraction on either side of an equal sign, you can cross multiply. So what do we say now? Cross multiply here, what do we get? We get 20 into b plus 16. Or I can simplify this and it can give me 2 over 3. No? Now I go into big numbers, so it's 2 into b plus 16 is equal to 3 times 16. You all agree with that? So how are we going to solve for b here? How are we going to solve b? Multiply it, get rid of the brackets, not so. So 2b plus 32 is equal to 48. We take 32 over, so 2b is equal to 48 minus 32 is 16. So b works out to be 8. So b is equal to 8. Okay. Is there any confusion there so far? Okay, so b is equal to 8. But have I answered the question? No, what must I still calculate? A and C still. So I'm going to write in what I've just calculated here, which is 8. Instead of B, I got now 8 here. So how can I calculate A? Looking at A, how can I calculate A? What do we have here? Right angle triangle. And how do I calculate my sides in a right angle triangle? Pythagoras. Let's go with Pythagoras. What do we get? So it's in the right here in triangle BDC. What can we say? 20 squared is equal to 16 squared plus A squared. Why? Pythagoras with BDC equal 90. The 20 squared is 400 minus 256 is equal to A squared. 400 minus 256 is 144, I think, yeah. It's equal to A squared. And the square root thereof is going to give you 12. Okay. That's going to give you 12 now. So there's your A, there's your B. So what must still be calculated? And how are you going to calculate C? Either Pythagoras, so that length being 24, 30, and you can work Pythagoras out. Or, I know that this is 2 over 3 is equal to, what is A? 12 over C, which is what you want to calculate. Now you guys solve for C for me quickly. The reason here is because also from similarity, no? Is that triangle BCD is similar to triangle ACE. But we don't need this reason here, no? Because there we have already written that, so that is suffice already. But I'm just writing it here to show you where this is coming from, just in case later on you open your book by mistake over the weekend, and then you know where it's coming from. Okay? People, we cross multiply, what do we get? 2 times C? 2C. 3 times 12? 36. Divided by 2 both sides. Therefore C is 18 units. We're given you centimeters, it will be 18 centimeters. We were given in meters, and so on. Now you guys understand? People, this is a mouthful, not so. You go home, not now, in the buildings, and you go through it again over the weekend. I'm not going to give you a lot of work, okay? Your homework is you're going to redo this exercise. I know it wasn't easy. For those of you who tried it. But if maths is so easy, then it wouldn't excite us, not so? Here we go. People, number 2. Number 2 is also on page 146. We are told to prove that triangle PMN is similar to triangle LMK. How do we prove similarity? We prove that the 2 angles of the triangles are equal. Right. So which angles are equal? Angle L is equal to angle P. Why? Alternate angles. Okay, it's going this way. Can we see too much? Okay. So angle N is equal to angle P. Alternate angles. Another one. K is equal to NY. Alternate angles. And then this will be the third angle here. Not so. Or I'm going to start off by saying in triangle PMN and triangle LMK. I'm going to go with the fact that KML is equal to angle PMN or NMP. Why? Why is that angle equal to that angle? Vertically opposite. But as I said, I could have gone with 2 alternate, it would have been 100% fine. Okay. Secondly, we say that angle L is equal to angle P. Why? It's alternate angles with KL being parallel to PM. That will get the same marking there. And then K is equal to N. Why? Why is K equal to N? Either alternate or third angle of triangle. I can either write alternate or that thing. Okay. Now what do we say? Do we have enough information to conclude similarity? Yes. So therefore triangle PMN is similar to triangle. So P corresponds with L, M corresponds with M, and N corresponds with K. And of course if we look here, it is the same. And what's our reason that we're concluding similarity here? Angle, angle, angle. Or A, the same. We will have something like this worth 4 marks. Okay, that's only if you want it. No? Kumla?
Yes.
Most of us don't want it, no? We're going to leave it. We're not going to study this thing. We say, okay, we will figure it out in the exam. People, this is one of those sections that doesn't work like it. Okay. The algebra you must figure out in the exam. No? Not the algebra also. Okay. People, the next question, of course, what did we say? A distance question will follow the similarity question. So we keep that information here. Alright. B. Calculate D and E. So where do we start? Start off by saying PM over LM is equal to MN over MK equal PN over okay, why? Because triangle PMN is similar to triangle LMK. Now say for argument's sake in the exam, okay, you didn't manage to prove the similarity here. I still go and say this here and I conclude. Okay, I can then assume that it is similar. You guys understand, eh? Alright, so let's see. So PM, what's the length of PM? PM. Oh, PM. That is the same as that, so it's going to be D. Not so. So D over LM is 7 equals MN D over MK E. So of course I can't use this. No? Equals PN 12 over, and there's my known ratio. Can you see that, people? So what can be determined at this point? We can calculate T. So I'm going to calculate D, cross multiply. Not so. D times 4. 4D is equal to 7 times 12. Not so. How do I get D on its own? Divide by 4 both sides. 4 going to 12, 3. 3 times 7 is 21. So D is now 21. So if that D is 21, of course that D is also 21. Which makes this D 21. So what can I conclude now? Therefore, I'm going with this now, no? Those two. Therefore, 21 over E is equal to 12 over 4. Now you solve for E for me quickly. Alright, so we cross multiply. 21 times 4 is 84. Or 4 times 12E. How do I get E on its own? Divide by 12 both sides. 4 going to 4 once, 4 going to 12. 3 times. 3 going to 3 once, 3 going to 12. 7 times. Now of course this cancels, so E is equal to 7. Okay. Nice, no? Beautiful. Then again, all sums are beautiful. So if you're a student that's getting an A for maths and want to retain that A, know what's going on. Okay. Now let us bring it down. Right, number 3. So Then number 3, we got this diagram here. Question says prove that P, Q, R is similar to triangle R is Q. Right, what do we know of those two triangles? To prove similarity, firstly, we need to prove the angles are the same. Okay. Right, let's go with it. Both are 90. So angle P is equal to angle QR is Y. 90 given. No? Another angle. Q1 is equal to is. Look like you didn't even look at the homework. So where's is from the Q? Q1 is equal to R1. Why? It's given equal. Can you see that, people? So we just need 2 and the third one automatically will be equal. So where do we start? In triangle PQR and triangle RSQ. What did you say? Angle P is equal to angle QR is, which is equal to 90. Why? Don't just say angle R, no? Because there's three angles at R. Then we see in this triangle, this one here, angle R1 is equal to, in that triangle, Q1. You see that? So angle R1 is equal to angle Q1. Why? It is given. You see if it's 2 arcs here and 2 arcs there, then that means to say it's the same. Okay? So in conclusion, we can say in this triangle, which is PRQ, in that triangle, we can say that PQR has to be equal to, in this big triangle, we already accounted for that R, Q1, it has to be this. Why? Why is that this angle here equal to this angle? Because of the third angle of triangle. So that is now enough to conclude that the two triangles are similar. So as a name for triangle, PQR is similar to triangle RSQ. Why? Because angle. Okay. Again, 4 marks in the bag there. Easily. We go through these sums, okay? Practice them. Look at B. B says calculate the length of F. So where do we start? We start by saying PQ over RS is equal to QR over SQ equal PR over RQ. Why? Because triangle PQR is similar to triangle RSQ. Okay. So PQ, what's the length of PQ? 9 over RS. RS is F, and that's what we want to calculate, is equal to QR. 15 over SQ. SQ. It's unknown. Equal. PR. PR unknown. Over RQ, which is 50. What do you notice here? I need to have at least one known ratio, not so. Do I have a known ratio here? No. Like a number of a number is a known ratio. Okay. So going back here, I need to be able to calculate SQ. If I calculate SQ, then I can use this here. Not so. Not so? So let's inspect SQ. SQ. Can I calculate SQ in this triangle? How are we going to calculate SQ? You can't, because I'll be shorting F as well. Can you see that, people? So let's go see the other one. Let's go with this. Can I calculate PR? Yes, I'm going to calculate PR. I'll take this again. Can you see that, people? So what do I say is in triangle PRQ. We have a triangle looking like this now. 90 PR1 Q1. That's not Q1, and 9, and this is 15. So I'm going to calculate PR by using Pythagoras. So it's 15 squared is equal to 9 squared plus PR squared. Why? Pythagoras with angle P equals 90 degrees. So 15 squared is 225 minus 9 squared, which is minus 81, is equal to PR squared. So PR is equal to 225 minus 81, 169, 225 minus 81, no, not 160, 144. 144. So therefore PR is what? Length of PR is 12. Now what can we say? That is 12. I can replace PR with 12 now. So 9 over F is equal to 12 over 15. That PR is being replaced here. Cross multiply. So it's 9 times 15 is equal to 12R. No, 12F, sorry. How do I get F1 is out? Divide by 12 both sides. So F is of course equal to, that cancels. 3 goes into 9 3 times, 3 goes into 12 4 times. 4 times 15 is 45 over 4, or 11 comma 25. Or it's 11 and a quarter. 11 and a quarter. You see how far? Yes, it's correct. People, is there any confusion here? It's a lot, no? Alright, but I'm sure you guys will conquer it. Okay. So for homework, I would like you guys to redo these 3, and then later this afternoon I will send you the link to this video. Okay. So if you're completely lost, you watch it again and again and again until you get it, and then you try and do it on your own. Okay, you should be able to get it from them. People, it's a very, very important section. You're going to use this all the way to grade 12. Okay, very important concept to understand. Right, so that basically brings us to the end of exercise 1 on page 146.